I'm now going to tell you puberty within the female and male body. I apologize for the crude drawings of both. I am not an artist. In the male body, very similar to the female body. In fact, they're the same until they hit the cells within either the testes or the ovaries. It starts out in the pituitary gland, which is about up here, where gonadotropin, or GnRH, is released, and then within the hypothalamus, LH, or luteinizing hormone, is released, and that moves down to either the ovaries or the testes and releases more testosterone in the boys by connecting to the Leydig cells of the testes, or releases more estrogen by binding to the granulosa cells in the ovaries. I'll tell you the mechanisms of steroids and non-steroids. Steroids are allowed to enter through a cell's membrane, and there they bind to the hormone receptor complex and can upregulate or downregulate proteins as the cell is needed. However, with non-steroids, the non-steroids bind to a receptor outside of the membrane, and then invokes change within the cell from there. All right, now I'm going to tell you what happens when someone has hypocalcemia and how the body tries to fix that. There are two pathways that the body attempts to fix this. First, it happens in the parathyroid. This is where chief cells stimulate the release of parathyroid hormones, or PTH. This stimulates PTH to go into the bloodstream and make osteoblasts slow down and osteoclasts speed up, so that not so much calcium is in the bones and is instead into the bloodstream. Also, what happens, if you remember from the last video, is cholesterol turns into cholecalciferol in the skin, which turns into calcidiol in the liver, which, with the help of 25-hydroxyvitamin D3 1-alpha hydroxylase, turns into vitamin D in the kidneys. Because of the release of PTH, now the small intestine knows that vitamin D is its friend. And vitamin D hooks on to a vitamin D binding hormone and travels down to the small intestine, where it then attaches to a vitamin D receptor, which stimulates the release of calbindin, which allows more calcium to be digested. Alrighty, take a look at my cool human. I'm going to show you how vitamin D is synthesized. It starts with cholesterol. Cholesterol is absorbed into the skin, and there cholesterol turns into cholecalciferol. That then travels down to the liver, where cholecalciferol turns into calcidiol. For calcidiol to turn into vitamin D, calcidiol needs to bind to 25-hydroxyvitamin D3 1-alpha hydroxylase, and this creates vitamin D in the kidneys.